Good evening students, today lesson SHM, simple harmonic motion. Simple harmonic motion. So first one, reference frame. Reference frame. So all observations made in a background, that is called reference frame. Board, wall is a reference frame. 2D space, 3D space also reference frame. So second, rest. With respect to reference frame, all the particles does not change with time. That is called rest. So board is rest, table also rest, wall also rest. So third one, motion. Motion. So with respect to reference frame, all the particles change from one place to another place. That is called motion. So two-wheelers, three-wheelers, man moving east direction or west direction, that is a motion. Next, translate types of motion. Types of motion. Types of motion. First one, translator motion. Translator motion. So motion of the body, motion of the objective from the particles have same displacement, same distance and same time. That is a translator motion. So translator motion, man moving and bus moving also translator motion. Same direction, same time. That is a translator motion. So translator motion have two types. So one is the rectilinear. Rectilinear motion, curvilinear motion. Curvilinear motion. Rectilinear motion, path taken also straight line. Path taken straight line. That is a rectilinear motion. Path taken curve. That is a curvilinear motion. Curved roads, example curved roads, banging roads. That is a curvilinear motion. Next, circular motion. Circular motion. The motion of the body along to the circumference of circle, that is called circular motion. So this is a circular motion. So here artificial satellites around the earth from certain height, that is a circular motion example. Next, rotator motion. Rotator motion. Rotator motion is motion of the body along with the fixed axis or whole axis. That is called rotator motion. Spinning top. Spinning top. Spinning top also rotator motion. Okay. Next, periodic motion. Periodic motion. A motion of the body which repeats equal interval of time, that is called periodic motion. So, earth around the sun, heartbeat, that is a periodic motion. Okay, pendulum clock also periodic motion. Motion of the body which repeats equal interval of time, that is called periodic motion. Next, oscillator motion. Oscillatory motion. So, oscillator motion, the motion of the body to and fro and back and forth has same path, that is called oscillator motion. So here pendulum clock, oscillator motion. Swing also oscillator motion. Okay. Next, harmonic motion. Harmonic motion. Harmonic motion, that is a function of sine or cos, that is a harmonic function. Sine cos function. Harmonic function have sine cos function. Simple harmonic motion, SHM. This is special type of motion. Simple harmonic motion. So here motion of the particle at mean position such that restoring force or torque is directly proportional to displacement and angular displacement. That is called simple harmonic motion. Condition of simple harmonic motion. Condition of SHM. So condition of SHM, that is the first one, oscillator motion. oscillatory motion, that is to and fro. Periodic motion, periodic motion, periodic motion. Third one, acceleration of the body, towards the main position. Towards the main position. Fourth one, acceleration is directly proportional to opposite displacement. Fifth one, restorative force is directly proportional to opposite direction of displacement. So conditions of SHM, that is first one, oscillatory motion, to and fro motion, periodic motion, a motion of the body which repeats equal length of time, acceleration of the body towards the main position. So acceleration is directly proportional to opposite direction of displacement. Restorative force is directly proportional to opposite direction of displacement from Hooke's law. Here, types of SHM. Types of SHM. So two types of SHM. One is the linear SHM. Second one, angular SHM. So linear SHM, the function of displacement with time. The function of displacement with time, that is a linear SHM. The function of displacement, angular displacement with time. The function of angular displacement with time, that is called angular SHM. Angular SHM. Linear SHM, loaded spring. Example, loaded spring. Linear SHM. So here F is proportional to minus x. The restorative force developed the spring. The restorative force helped the body towards the main position. The body towards the main position. So restorative force helped the body towards the main position. That is called the restorative force. For Hooke's law, F is proportional to minus x. So this is a linear SHM. The angular SHM, simple pendulum. Angular SHM. Example, simple pendulum. So restorative force helps the body towards the main position, that is called restorative force. From Hooke's law, F is proportional to minus x. F is proportional to minus x. So F is proportional to minus x. F equal to minus kx. K is the spring constant that units K equal to m by x. So K is equal to Newton by meter. So K units Newton meter mass. SI unit. CGS unit die centimeter minus 2. Dimension formula dm. So ml square t minus 2 by L. L cancelled. L inverse ml t minus 2. ml t minus 2. ml t minus 2. Dimension formula ml t minus 2. So this is a spring constant. K is the spring constant. So Newton second law, since F equal to ma. F equal to ma. So ma equal to minus k into x. So a equal to minus k by m into x. So k by m equal to omega square. So a is equal to minus omega square into x. So a, that is a acceleration. Acceleration equal to the rate of change of velocity, that is called acceleration. So dv by dt equal to minus omega square into x. So dv by dt, that is a dv by dt, dv by dx into dx by dt, that is equal to minus omega square into x. So dx by dt is equal to v. Dx by dt, dv by dx into v is equal to minus omega square into x. So v dv equal to minus omega square x into dx. Both sides have integration. So v square by 2 equal to minus omega square into x square by 2 plus c. C is the integration constant. C is the constant. So in extreme position v is equal to 0, x is equal to a. Find out the c. C equal to question mark. So 0, the first equation. 0 equal to minus omega square a square by 2 plus c. So c is equal to omega square a square by 2. The second equation. Second equation replaces the first equation. That is a v square by 2 equal to minus omega square x square by 2 plus omega square a square by 2. So both sides cancel. So v square is equal to, so omega into root of a square minus x square. That is a v function. V is the velocity function. So velocity of the SHM v is equal to omega into root over a square minus x square. A square minus x square. Here v means dv by velocity, the rate of change of displacement, that is called velocity. So dx by dt equal to omega into root a square minus x square. So here dx by root a square minus x square into omega into dt. So both sides have integration. So this is sin inverse x by a function. Here's the integration dx by root of a square minus x square. The formula sin inverse x by a is equal to omega into t plus pi. Pi is the constant. So x by a equal to sin omega t plus pi. So x is equal to a sin omega t plus pi. This is the displacement of the SHM. X is the a sin omega t plus pi. X is the displacement, a amplitude, omega wave velocity. That is a angular velocity, t time phi phase. Angular velocity. Omega is the angular velocity. T time phi is the phase. Amplitude, x displacement. Next video, x is velocity, acceleration and energy.